Okay, so this is the stoichiometry question from the 2010 DEB mock, so question 11A. And the question says, calcium carbonate reacts with hydrochloric acid according to the balanced equation. Okay, so that they give you the equation, and the carbon dioxide that is produced reacts with calcium hydroxide according to the second balanced equation that is there. So what mass of carbon dioxide is formed when 10 grams of calcium carbonate reacts completely with hydrochloric acid? So what you're being asked about in that question, they're asking you what mass of carbon dioxide is formed when you have 10 grams of calcium carbonate. So what we've been doing all along, we find our number of moles of calcium carbonate, look at the ratio, find our number of moles of our carbon dioxide, and we're able to find our mass again using that N is equal to mass over relative mass relationship. Okay, so first of all, we need to find the number of moles of our calcium carbonate. In order to do that, we need to find our mass and we need to find our relative mass. We are given the mass in the question. We have 10 grams of calcium carbonate. Calcium carbonate is CaCO3. So we need to find our relative mass. We just need to add up the atomic masses of each atom that is inside there. So our MR for CaCO3 is going to be, well, calcium is 40, carbon is 12, and oxygen is 16. We have 3 of those, so it's going to be 16 multiplied by 3, so that is 48. So our MR for calcium carbonate is 100. To find our number of moles, it's going to be our mass, which they give us in the question as 10 grams over 100, and that gives you 0.1 moles, right? 0.1 moles of calcium carbonate. Now, if we look at our balanced chemical equation, if we just concentrate on the calcium carbonate and the carbon dioxide, we see that 1 mole of calcium carbonate will produce 1 mole of carbon dioxide, right? They're in a 1:1 ratio. There's no number or anything before the calcium carbonate or before the carbon dioxide. So they're in a 1:1 ratio with each other. So the number of moles of calcium carbonate that you have is the exact same as the number of moles of carbon dioxide. So if you have a ratio CaCO3 to CO2, well, that ratio is 1:1. So if you have 0.1 moles of calcium carbonate, well, then you have 0.1 moles CO2. We're not asked for the number of moles, we're asked for the mass. So if we take this equation, our N is equal to mass over relative mass. Again, if we rearrange that, our mass is equal to the number of moles multiplied by our relative mass. If we just do a quick calculation of our relative mass of carbon dioxide, carbon again is 12, oxygen is 16, we have 2 of those, so it's going to be 12 plus 32. So that is going to be an MR of 44. So our mass is going to be 0.1 multiplied by 44. So our mass is equal to 4.4 grams of CO2. Right, and that's the answer that we were looking for. Okay, so that's part 1 of the question done. If we look at part 2 now, alright, what is the volume of that amount of gas at room temperature and pressure? So the important bit here was pointing out that it's at room temperature and pressure. Okay, so in this case, we're not going to be multiplying by our 22.4 that we would at standard temperature pressure. We are going to be multiplying by 24 litres. The volume, you multiply your number of moles by your 24 in this case. So part 2 here, so your volume of CO2 is going to be your 0.1 moles multiplied by 24 litres, and that gives you an answer of 2.4 litres of carbon dioxide. That's what you have. So that's your answer to part 2. So 4.4 grams was your answer to part 1. 2.4 litres, your answer to part 2. If we look at part 3, what mass of calcium hydrogen carbonate would be formed if that amount of carbon dioxide reacted completely? So this is probably where this question might trip a few people up, because you have two equations in this question. In the first equation, there is no number before the carbon dioxide. It's just CO2. And we found below that we had 0.1 moles. Now, this second reaction just leads on from that. That same carbon dioxide reacts with then your CaOH2, which is actually part 4 of the question, is calcium hydroxide. So that reacts with calcium hydroxide. Even though there's a 2 in front of the carbon dioxide down here, your number of moles of carbon dioxide hasn't changed. It is the same quantity, it's the same amount of carbon dioxide. What this is saying is that you have twice the number of moles of carbon dioxide as you have calcium hydroxide, or your calcium hydrogen carbonate that you produce also. So your 0.1 moles actually stays the same. Alright, you don't double it, because you have this, it's the same CO2 that is starting off up here. Alright, and then it reacts with calcium hydroxide. Your number of moles does not change. It is the same quantity that you have, only that the 0.1 figure is twice the number of moles of calcium hydroxide that you have. So if we look at that, I might actually cut the equations out and bring them down a bit further, just so we can see. Yeah, okay. So part 3 of this question is asking you for, let me just double check, the mass of hydrogen carbonate. Okay, or calcium hydrogen carbonate. So you're trying to find the mass of your calcium hydrogen carbonate. We have 0.1 moles of CO2 from up here. That is the same figure as down here. So if we want to find our number of moles of CaHCO3, alright, you have a 2:1 ratio, so 0.1 moles is twice the number of moles of calcium hydrogen carbonate you have. You have 2:1. Okay, so you have 0.1 moles of carbon dioxide, you have half that amount. Right, there's a 1 in front of your calcium hydrogen carbonate. So it's going to be 0.1 over 2. Will give you a number of moles of calcium hydrogen carbonate. There's a 2:1 ratio, so that means you have 0.05 moles of that CaHCO3. 2. Okay. Again, they didn't ask you for a number of moles. Alright, you would more than likely get marks. You would probably get 3 marks for saying that. Okay. So that would be half your question. The other half of the question would be finding the mass. Again, your mass would be your number of moles multiplied by your relative mass. If we find the relative mass of our calcium hydrogen carbonate, calcium is 40. Hydrogen is 1, but you have 2 of those. So that is going to be 2. Carbon is 12, but again you have 2 of those. That's going to be 24. Oxygen, you have 6 of them. Alright, you have 3 multiplied by 2, so you have 6. So it's going to be 16 multiplied by 6, and that is going to give you 96. So your MR of your calcium hydrogen carbonate is 162. You have 0.05 moles. multiplied by 162, and that gives you 8.1 grams of CaHCO3. Okay, and that's the end of your calculation. Again, as I mentioned, part 4, that is called calcium hydroxide. All right, we're not really at the point yet of knowing the names of many compounds or anything. We will get to know them over time. It's more so just seeing them, and we will know that OH is an hydroxide group, so calcium hydroxide for that. Okay, but won't be worrying too much about that at this point. More so the calculation is what we're looking for here. Okay, so any questions, particularly maybe there might be some people wondering still about why you have 0.1 moles of carbon dioxide and you still have 0.1 moles down here, even though there's a 2 in front. You're just showing the ratio for this particular equation. Okay, so the number of moles isn't changing, it's the ratio that that equation is showing. Okay,